Hello, so today I'm looking at M3 International A-Level May 2015. This is question 4. So, a particle of mass 3m is attached to one end of a light inextensible string of length A. The other end of the string is attached to fixed point O. The particle is held at point A, where OA is horizontal and OA is equal to little a. The particle is projected vertically downwards from capital A with speed u, as shown in figure 2. The particle moves in complete vertical circles. Show that u squared is greater than or equal to 3ag, and this is for 7 marks. So, the fact that the particle moves in complete vertical circles is very important because it means two things. It means that, first of all, there's enough kinetic energy here to mean that it is able to move high enough up here so that the speed is greater than 0 here, and also that it's going fast enough that the tension at the top is greater than 0. So if we first of all try to write down an equation for the energy, so I know conservation of energy, so I know that the kinetic energy at A will equal the kinetic energy at B plus the gravitational potential energy at B. And I'm going to take the level of no gravitational potential energy to be the level of O. So kinetic energy at A will be half times the mass, which is, watch out, it's 3m, not m, times the initial speed squared will equal half times the mass times the velocity at the top squared, so I'll call that v, plus the gravitational potential energy, which will be, we used to use the formula mgh, but that in fact is the mass, which is 3m times g times the height above O, which is A. I can see that I have 3m everywhere, so I can divide through by that, and I could double everything, so that I end up with u squared is equal to v squared plus 2ga, and that gives me a relationship between the initial velocity and the velocity at the top. So v equals speed at top of circle. Okay, so that is not enough. So that basically means that in order to end up with this thing, I need to find some kind of expression for v squared. So what can I do? Well, I can look at the forces and the acceleration when it's at the top, because that is kind of the danger point, if you like, because at the top I need the tension to be bigger than or equal to 0 for this to be for the particle to follow a complete circle. If the tension isn't big enough, then the particle will kind of swing around here, and then at a certain point it will leave the circle and start just moving freely under gravity. So this tension here is very important. So what forces are acting? Well, I've got the weight, 3mg, plus the tension, also acting towards the centre of the circle, and I've got the acceleration towards the centre of the circle. I could use r omega squared or v squared over r, and as I need a v squared, in this case I'll use v squared over r. So it's v squared over the radius of the circle, and in this case the radius is a. So using Newton's second law towards the centre of the circle, then I get 3mg plus t equals the mass, which is 3m, times the acceleration. So here I know that t needs to be bigger than or equal to 0. So if I rearrange this for t, then I get t is going to be 3mv squared over a minus 3mg, and I know that's going to be bigger than or equal to 0. So therefore I know that v squared, 3m over a, that will be bigger than or equal to 3mg. By adding 3mg to both sides, I can divide both sides by 3m. 3m is definitely positive, so there's no problem with the inequality sign, and so v squared will be bigger than or equal to ag, And now popping that in to that first line of the equation, so I'll call this 1, I'll call this 2, so sub 2 into 1. Therefore, I can see that, therefore, u squared is going to be bigger than or equal to ag plus 2ag, and so I get u squared is bigger than or equal to 3ag as required. Oops. Okay, and that is the first part of the question for 7 marks. Then in part B, it says, given that the greatest tension in the string is 3 times the least tension in the string, show that u squared is equal to this thing. So I know that the greatest tension in the string is going to happen at the bottom, and the least tension in the string is going to happen at the top. So let's say at the top, where the tension is the least, let the tension be T dash. So therefore at the bottom the tension will be 3T dash, and that's just putting this into these two expressions, T and 3T dash and T dash. Okay, and now I can see, look at these two different situations. Okay, so at the bottom then, I know what will happen. Okay, when it's at the bottom, I've got 3T dash, I've got 3mg, and I've got the acceleration will be whatever the speed is over a, and let's call that w. So the acceleration will be w squared over a. Now, using energy, I've got that the energy in the first place, half times 3m u squared, which is the energy at A, plus the gravitational potential energy that it has there, 3mga, will equal this energy, kinetic energy at the bottom. So basically, I'm saying that the kinetic energy and the potential energy when it's at A will equal the kinetic energy here. So I'm basically taking this bottom level to have no gravitational potential energy at this point. Okay, dividing through by 3m, I get this, and doubling everything, I get this. So I get that w squared is u squared plus 2ga. And doing Newton's second law, I get 3t dash minus 3mg equals 3m w squared over a. So I get 3t dash minus 3mg equals 3m over a multiplied by what w squared is. So tidying this up a little bit, I've got 3's everywhere. I get t dash minus mg equals mu squared over a plus 2g, mg, sorry, because here the a's cancel. And so now I get that t dash is mu squared over a plus 3mg. And then if I do the same process with everything that I have at the top, now the tension at the top, I can basically steal some of that work that I did already. So if you look at the work that you did in part 1, so you ended up with this where v was the speed at the top, we had this equation here, and so we've basically got the same thing as this, but it's a t dash now. So we have so using this equation, I've got 3mg plus t dash equals 3m times v squared over a. But what is v squared? V squared is going to be u squared minus 2ga. Okay, using these two equations together. So I've got 3mg plus t dash equals 3m u squared over a minus 6mg, multiplying out this, so because the a's cancel here, and so then I get t dash is 3m u squared over a minus 9mg. So now I've got t dash here, so I can put these two things equal to each other. So I get, let's call this one 3, let's call this one 4. So basically what I'm saying is 3 is equal to 4. So that gives me mu squared over a plus 3mg equals 3mu squared over a minus 9mg. So taking away mu squared over a from this, I get 2mu squared over a. Adding 9mg to both sides, I get 12mg here. So dividing these both by 2, dividing both by m, multiplying both by a, I get that u squared is 6ga as required. Okay, so that last part of the question was worth 5 marks. I hope you found that solution helpful. Do click like if you liked it, and good luck with your studies.